And the panel will be led and moderated by Joel Young of LinkedIn. Welcome.
Thank you, Nisha. So I'm Joel. I lead the machine inference infrastructure team at LinkedIn. You hear a lot of discussions about machine learning. My team doesn't do machine learning, we do machine doing. We have plenty of people doing the machine learning. I also am part of the leadership team for LinkedIn's Productive Machine Learning Initiative, rebuilding our end-to-end machine learning stack. I am joined today by 5 awesome leaders from across the industry. We have, introduce yourselves.
Hi, good afternoon everyone. I'm Pranav from Google AI. I lead their teams working on conversational AI and personalization AI technologies. We are a group of scientists and engineers, about 50 of us. We do both the research and then develop the vertical specific infrastructure.
The ML infrastructure team builds foundational infrastructure for ML use cases throughout Airbnb. And the applied ML team looks to build foundational models that can be leveraged throughout Airbnb, sometimes as kind of foundational features.
Hi, I'm Faisal. I lead personalization infrastructure at Netflix. And my team is part of a larger applied machine learning org focused on one core element of the Netflix product, which is personalization and search and messaging, so content discovery for our members. My team is sort of a localized, centralized team in the sense that we're focused on one large vertical, but within that, various focus areas, we look for horizontal leverage, and so we can benefit from the diversity and the commonality between the various use cases. Happy to be here.
I'm Sandhya Ramu. I lead the offline data and AI SRE teams at LinkedIn. My team is responsible for the grid infrastructure like Hadoop, Spark, Presto, so on, and also the data movement, both egress and ingress from all different sources. Also the AI platforms, like there are online serving and member facing, be it search, and cloud, so on and so forth. So excited to be here. Thanks for having me.
I'm Aditya Kato. I'm an engineering manager on the AI infra team at Facebook. And we build a bunch of infrastructure and tooling to make machine learning engineers more productive. Everything from feature engineering, data pre-processing, training and evaluation, and an inference cloud so that you can push your models to production more quickly. We also have a layer on top of all of this to make the entire process and glue it together, and also lineage across these so that you can actually tell which data a model is trained on. This becomes very useful, and I'm pretty sure we're going to end up talking about some of this. I'm excited to be here. Thank you for having me.
Thank you all. So the way we're going to structure this is we're going to talk for a chunk of time, and we have about 10 to 15 minutes for questions from all y'all. So as something comes to mind, maybe take a quick note, and we're going to have a big chunk of time to talk about. As you think about things, we've got a few different kinds of people on the panel. Andrew is a product manager. So as you're thinking about the things, and if you have questions, how do you think about things from the product perspective versus the engineer, builder, etc. perspective? Please put them on the table. Sandhya is our only SRE representative. I know that her and her team have saved me, or more accurately saved my customers many times when we make mistakes. Keep that in mind also as you're thinking about the questions and perspectives that you want to dig into later on. So, speaking of that, one of the key questions that drives how we build, what our job is building out the ML infra, keeping it operable, is exactly who are our customers. Thinking about whether they're ML engineers, whether they're data scientists, whether they're all the engineers in the company, who you're building for drives what you build. So, Andrew, do you want to, as a product manager, how do you think about this? Who are your customers?
Great question. So at Airbnb, we really have many different personas that we look for, who are our customers from ML infrastructure side. We have the ML engineers. These are usually people who can build their own infrastructure, who understand how to build applications, who understand what it really takes to do the entire software development lifecycle. We also have data scientists. This, I know, is a terminology that's relatively different across which company you work for. For data scientists at Airbnb, it's less code-based, more towards kind of doing research and kind of developing a lot of different models. And it spans across from some data scientists who focus on analytics. Some individuals who focus on doing analytics, building dashboards, and then other data scientists who build out models. And a lot of these models could eventually be used in production. And the last one that really comes up, which isn't talked as much, is the application engineer as well. And so for our infrastructure, a lot of the core users would be the ML engineers and data scientists. Data scientists develop a lot of the models. ML engineers may sometimes develop models, but they also do some of the work to implement it back into the infrastructure or the production service. If a data scientist wants to pursue building a model, they actually pair up with an application engineer who can then take the results of the model and then plug it back into the system. And so we find that the number of users and the archetypes of different users for our ML platform really varies. And so we always have to consider this when we're building out new features so that we can make sure that each different persona is well thought out and make sure that they all have a great experience.
Faisal.
A lot of what you've said resonates with me. Similarly, we have research scientists as well as the application engineers and ML engineers. One thing that is slightly different in the Netflix model, at least in the vertical that I focus on, is there's a sort of a hybrid of what we call the algorithm engineers, where they have sort of the chops of our research scientists, understand the math and the statistics behind developing models, but they're also trained on productizing things. And so having them as our customers informs us on the kind of frameworks and libraries that we have that we build. And so, for instance, things like good software engineering design, right? API extensibility, all of those things are important because we are essentially targeting to a set of customers who are equal part software engineers as well as research scientists. So that helps.
Awesome. Aditya, Facebook, who are you building for?
That depends on which team you're asking about. So what ends up happening is that we have a bunch of teams that we're tying together to make it very easy to go from one stage to the next. I think what Andrew was talking about in the research to production side is exactly the kind of thing that we want to do with FAIR, the Facebook AI Research Group. But more from the product point of view, we're trying to make it easy so it's point and click for training a model. You point it to your data. It will train a model based on the research that FAIR has already done. And again, it's one button push to the inference system. It doesn't always work like that, but it's most of the time if you're doing something inside of a closed box use case, it works. Application engineers typically find this a lot easier to get to from one stage to the next stage if we provide the right tooling. So what you were talking about, we've talked about ProML in different scenarios, but that's what we're aiming for as well.
Awesome. Thank you. So one of the, Sandhya is here on the panel. So Sandhya, as we build this stuff, what do you wish that the five of us builders actually would keep in mind? What is important with keeping the systems operable?
Yeah, that's a great question. There's a long list, but let's whittle it down to a few, right? I think the first one would be understanding the decision point when you will move from experimentation to production, because oftentimes there's a long lead time before we can take things to production. Working with the platform owners early on in the development life cycle to give us enough lead time and as well heads up around planning things, around infrastructure is definitely one thing. The second thing would be oftentimes what happens is people build flows and put things in production, but they don't go back and retry their flows, right? Either because the product priorities changed or people have moved on to different teams. There's a ton of things that lies around in production which may not necessarily be adding value due to various reasons. I think having a craftsmanship initiative to go back and revisit some of these things and confirm the need for having these things in production and being proactive about getting rid of things that are not necessarily necessary anymore is the other thing I would highlight. The third thing is around capacity management in general, right? It's a joint ownership between platform owner and customer, right? I think there's a ton of metrics that not only make it visible from a cost to serve standpoint, also the efficiency standpoint for the platform users. Now, how do we ensure there is accountability as a joint team and keeping the utilization to the most optimal way? I think those are probably the three things I would highlight and aspire that all the operable aspects of it are built early on.
Thank you.
If I may just jump into that, I think the last point you mentioned was resonating a lot with me. There's joint ownership of cost, and obviously there's no infinite resources, but oftentimes we run into challenges where research scientists and models are hungry for data and therefore compute power, and so they often want to be able to do the most, the most with the most resources possible. And so, but when you talk to the product managers, you talk to the research scientists, we often find that not everything has to be at the same high priority. For instance, if you're trying to do a backfill of a new model that it's just early exploration, it's okay to let the backfill run for 5 days as opposed to 1 day if it's a lot of data, and that would have a substantial difference in the amount of resources that it may use. So having those conversations oftentimes helps, and if you can have good metrics and cost dashboards to point out why some of the leaderboards or shame boards are helpful.
Nice. Pranav, can you talk a little bit about your team's perspective on operability?
I think operability is, especially when it comes to ML systems, because people expect these to deliver results that are both explainable and predictable, right? So, and by people, I mean both the engineers that are using this infrastructure, but also the end users. And it really becomes important that we support it in a fashion where it's giving, like we can repeat those results in a predictable fashion and the quality that the end users are expecting.
Great, thank you. So one of the things that is transitioning in this industry, and different companies are in different places in the transition, is the role of containerization and the role of deep learning in what we build. And interestingly, with things like Kubeflow and stuff like that, these two are not independent of each other. So in this question, Aditya, can you talk a little bit about how this is impacting what you are building?
So at Facebook, we used homegrown containers, and one of the things that did happen when we went from a non-containerized system to a containerized system, reliability improved, scalability improved. We could end up co-locating a lot of the work that we were doing across the entire fleet of machines that we had. In general, the reason that we used, or I don't know how to put it, the reason that we told everybody that we wanted to move to containers is because we wanted more security. We wanted to be able to make sure that we couldn't get resources outside of what was supposed to be allocated, but also we couldn't get data outside of what was supposed to be available. And that was one of the major reasons for containerization. It's helped us on a variety of levels, including exposing new types of hardware to models, to training right now. And we're expecting to continue on that part. We use different containerization mechanisms for inference and for training. I'm hoping that as our containerization evolves and catches up with Kubernetes and Kubeflow, we'll actually be able to use the rest of the benefits that containerization can provide. But I feel like we're still a little further behind in the game because we're using a homegrown piece.
Cool. So my understanding is in FB Learner Flow, you're heavily engaged with Cafe 2, PyTorch, of course.
Yes.
How do these models flow into production? Is it using a containerization framework, or?
Yes, it is. It's actually using a packaging and containerization framework. What ends up happening, because of the way that Facebook is set up, when FB Learner Flow actually tries to create a mechanism for training, it builds the package with Cafe 2 or PyTorch along with whatever other code there is to actually do the training. And then we ship that out. The one advantage that we see of this is that we don't have to deal that much with versioning, but the one disadvantage that we see of it is that the package size, the container size gets very, very, very large. So there are advantages and disadvantages to both of them, and we chose one to make our life easier so we could actually move faster on shipping changes to PyTorch and Cafe.
Thank you. Pranav, how are you guys thinking about it at Google?
Yeah. So Google internally, we use this system called Borg, which has inspired Kubernetes, which is widely used both in Google Cloud and beyond. For ML specifically, I think containerization or something like Kubernetes is really important, because ML, as we know, tends to be very resource intensive, especially the research side of ML, and that means resources aren't very predictable. Like if I do like some training research, it might happen in bursts over a few days as opposed to consistently over weeks or months. And being able to support that in a fashion where you can use those resources on demand, I think containerization or something like Kubernetes makes it much easier. You can tap into like the residual resources across lots of data centers and lots of machines, and I think that has significantly increased the amount of ML research and development that we see, as opposed to like the old model of like dedicated machines and stuff like that.
Nice. So one of the things that I found kind of fascinating is sometimes there's this feedback loop between what we need for ML infra and deployability and the technology stack. And some companies, it seems that containerization across the company is driving how we think about our ML infra. In other circumstances, like for example at LinkedIn with Kubernetes, it's what ML infra needs that's driving where we're going with the containerization technologies. Sanjay, can you talk a little bit about?
Yeah, absolutely. I think like Pranav mentioned earlier, there is a big demand for containerization, primarily because the older way of waiting for dedicated clusters for your own use cases won't scale, right? And it is not agile to quickly turn around. I think having a bunch of Kubernetes clusters, both for CPUs and GPUs, is the way to go, where we quickly spin up containers with the aspect of experimentation, which moves really fast, and it also gives a lot of autonomy for the ML developers, so they can iterate faster rather than waiting for some of these libraries to be available in the larger cluster, which takes much longer to go through the life cycle of rollout to production. I think that's the primary driver at LinkedIn. We are still tapping into it, very initial phases, but we have a long way to go before we can make it accessible to every single developer out there who uses machine learning or aspires to do it. And I think ProML is also another huge initiative that is pushing across the company, not just the AI team at LinkedIn. So looking forward to go big on that front.
Thank you. So early on in my time at building the infra, we had this 10 years of logistic regression rolling every recommender system. And maybe as a result of this, our systems had become extremely tuned. And some of the teams were even going so far as taking their models apart, looking at the inner product that's used to drive logistic regression, doing partial sums caching on the components, separating and applying the link function to the scoring in order to get every last drop of cost to serve. This was awesome, really, really efficient, and completely not agile. It would take quarters to change anything in how the models work, because it had to be worked down to the lowest layers of the infra. Andrew, as you're looking at designing the products, how do you think about balancing things like cost to run, cost to serve, cost to train versus agility for your customers?
Great question. I think the key thing in how we've kind of wrapped our heads around cost is really building the visibility for our downstream users. It's tough for infrastructure teams to be the owners of cost when it's hard to have visibility into all the downstream use cases using our infrastructure. And so it comes down to building a lot of trust with users and allowing them to have the visibility into how much cost they're running, and making sure that they're doing the cost-benefit analysis to make sure that their models that they run are actually beneficial to the company. One thing that really stuck with me from a coworker of mine, he mentioned that one of the key things with cost is always baselining first. And the one that he talks about is before he joined Airbnb, he was at this company and they would invest into building a neural network for their search results. And after investing about 6 months to a year, they actually found out that a simple popularity sort actually worked a lot better. And so you can imagine that overall cost of running this, overall cost of training this, overall cost for inference, nothing even close to that baseline model, not even a model, just baseline popularity sort. And so I generally just, from an Airbnb standpoint, recommend to baseline first, understand where you can get with something simple, and then from there iterate on it and see how much better you can make it, and then do the analysis of if we were to make it, precision 5 percentage points better, how much more does it deliver to the company? Is it worth it? Especially in ML when especially more complex and heavier models take a lot of resources. You really do have to take a look to see if increasing it by 0.5% is worth it or not, and do that kind of cost and benefit analysis. And so I think, long story short, we as infrastructure try to make it very, very clear to our upstream users just what the costs are for their model, and then the shared cost of, let's say, capacity, of having that capacity that's unused, we build it into how we manage costs for our team. And we try to verify that we actually need that staging cluster or test cluster to make sure that there are no production issues. And so it's a complex formula, and this is kind of how we've ended up today. I imagine it'll change in another 3 to 6 months as we figure out more costs that come into play.
Cool. Sandy, do you want to talk about LinkedIn
Yeah,
perspective?
I think very similar to what Andrew was mentioning, right? I think as platform owners, it is very hard for us to be responsible for the cost, right? And primarily, I think understanding the business needs of the various customers within the company, right? All the way from sales insights, BizOps, data sciences, AI teams. Each of those teams have a different use case, and I think their needs are very different and need different speeds of delivery, right? For instance, maybe at LinkedIn at the moment, our sales insights teams are looking to leverage GPUs because they don't need it now, but I'm fully being aware of they will get there at some point, planning ahead. The other aspect is, again, making both costs as well as efficiency transparent to them, right? That way there is a combined ownership, and we can go back and drive accountability for their individual organizations. Specifically with AI teams, at the moment today, we do struggle a little bit because AI teams want to move faster and they want things now. However, there are business costs associated and lead time. So we try to meet them in the middle, wherein how do we cater to their needs and provide business justifications to our production infrastructure engineering teams, working with the vendors proactively to make sure they can plan ahead around when they need some of these delivered and the quicker turnaround. Also exploring Azure Cloud, wherein for the non-standard SKUs, can we leverage the cloud rather than relying on the on-prem, which is taking much longer. Again, it comes down to though we need to be agile, if we throw GPUs and CPUs at a problem, which is not necessary, you will quickly manufacture scale problems. And being aware that cost to serve is a very essential component of agility, and working towards balancing the both is the way to go. That's what we aspire to do at LinkedIn.
Thank you.
So if I can add on, I forgot to answer the second part of your question, which was, so one thing that we try to do in infrastructure is keep things extremely flexible, especially for ML infrastructure. And this is where Joel kind of mentioned, do you fine tune? But now you're paying the cost of long term of changing really fine-tuned infrastructure, which can take 6 months or longer. So at Airbnb, we've really taken an approach of being incredibly flexible at this time, because the ML kind of, I would say the industry and the state of the art is pretty dynamic at this time. We find that there's a lot of different frameworks out there. There's new hardware being applied as well, whether it's TPUs. And so overall, our current approach is keeping things very, very flexible. If the ML industry does become a little bit more stagnant and static, and the methodologies start consolidating into, let's say, a single ML framework or a specific type of hardware, and the innovation is slowing down, Airbnb then will kind of take a stance of then building in the fine-tuning the models and fine-tuning everything for cost optimization. But currently at this time, we keep it very flexible. We leverage a lot of Docker containers to make sure that people can use the libraries they want to. We're agnostic to ML frameworks. We don't really impose whether they should go with TensorFlow, PyTorch, or MXNet. We allow our users to use what they would like to use. Just because Airbnb is also full of engineers from many different companies who are used to different types of frameworks, and it's always hard to force everyone to use a single framework, and that's always a losing battle. So making sure that it's highly flexible and allows users to use what they know best has been really successful for us, and that's kind of the foundation of our infra.
Yeah, actually, when we started FP Learner, that was exactly the mechanism that we took, and which is why going back to the containers thing, having a flexible mechanism of being able to stuff whatever you want in the containers makes it very easy for us to add the frameworks that people want to use.
So one of the things that is really popular now in a lot of the literature, a lot of conferences, is deep embeddings. Another thing people are talking about is transfer learning. Now, both of these things come with the ideas of they're leverageable by other teams. Oh, in the software world, we've figured out some rules of thumb, some engineering rules. We have things like semver with major numbers, minor numbers, patch versions, and if I change my ABI, I need to bump my major number version, things like this. For sharing of ML artifacts, features, embeddings, models themselves, things are kind of nebulous. So let's dig on that a little bit. So, Aditya.
This is a very, very long answer to a very, very short question. But essentially, the idea of sharing features is, one, necessary, because the amount of, we didn't actually cover cost of storage, cost of feature generation, when we were talking about cost of serving.
Yeah.
That's actually huge. It's massive. In fact, in surveys that we did, the cost of feature engineering as a process is 60% of an ML engineer's time. Even if you could reduce that by a little bit, by sharing features that some other team has done, that would be a massive amount of saving. This is just from the perspective of wanting to share. I'm not saying it has to be completely open. There have to be safeguards in place, and which is where policy-style frameworks come into play. Are you actually supposed to be able to use this feature for training this X feature for Y kind of model, right? These are questions that we start answering. And I think as infra engineers, we can build the framework, but it's up to business, it's up to applications to actually define what those policies need to be. we just need to make sure that it's enforceable throughout our systems. That's my short answer on, or kind of short answer on how to share features. At least that's the philosophy we're taking at Facebook.
Pranav, how are you thinking about sharing at Google?
Yeah, I think this is a very important area that I believe will be one of the major factors driving the next phase of growth in AI. And the reason is, today when most engineers or scientists have to build AI models, they go and start from scratch. Okay, give me the raw data, give me the end problem, and I'll build a model from scratch. And this is not really sustainable when you have thousands of engineers across a company or across an industry building models. And then you need to start componentizing the model, right? So you need to break it into components that people across the organization can start using. So I want this subset of components and I would use that. Some other team might have a different subset that they want to use. And that makes the work that's being done by one team highly reusable by several other teams. So this is a very important area. When we talk about components, there are several different types of components. So one is the data component itself. And even within the data, there's two parts. So there are intermediate data deliverables within the models, things like embeddings that could then be shared across models. There are the end predictions that the model generates that could then become inputs to other models. The second category is code itself, code or modules within models. And even there we are seeing a lot of reusability happening, increasingly happen, but not as much as is needed. So if you take the same analogy in something like C++ code, or Python code, people are writing libraries all the time and then reusing other people's libraries. I think that same phase of growth is going to happen with ML.
If I may add, so a couple of things come to mind. One, when it comes to sharing features and the computation of features, often it's a bit of a slippery slope in this sense that the freshness of a feature, the context, the request context that went into computing a feature may be very pertinent to a particular use case that was designed at a certain point in time. And so you can't just arbitrarily pick something up and short of trivial features. So that's one of the things that is obviously playing on people's mind. We've had a couple of approaches to address that. One of the things that we've done is, so we have a common platform library where we allow people to essentially promote features that they believe are a good generalizable, in a good generalizable state. And then with that comes the responsibility of making sure that there's a good documentation and reproducibility around exactly what is the intent behind this feature. So that ability to promote, but it's a conscious, explicit decision as opposed to going to a discovery tool and just finding something that you think looks right. The other opportunity for sharing is, I think what Pranav hinted at was feature models. So when you have a large ensemble there is oftentimes fully developed models that are essentially a well-defined output, and their inference results can be used as an input score into, let's say, you're doing 3 different types of rankings, and you have a very similar set of models that could go into it as features. And so the contract there is well-defined and clear in the sense that however you created your data set, you are presenting a prediction, and that's easily understandable, and that then feeds into other models. So those are the 2 things that we've played with.
Nice. And that's actually really cool. We try to do that on a smaller scale. The one thing that we faced a bunch of challenges. I'd love to hear a little bit later about what you do. Is quality of service for features when not the infrastructure team, when a product team is maintaining it, became an issue for us. So I'd love to hear a little bit about that.
Yeah, it's certainly a challenge. In our case, because of our sort of close partnership with the algorithm engineering team, they do maintain the ownership of the models. We just provide the platform on which they could have those discoverability.
So we've touched on it a little bit. One of the things when we're building these platforms, as has been touched on, the industry is evolving extremely quickly. New machine learning techniques are coming out every day. New robust platforms are coming out on at least a quarterly basis. As you're thinking about your platforms, how do you keep extensibility? What does extensibility mean for you as you're designing? Andrew, can you touch a little bit on how you're thinking about it?
Yeah, for extensibility, I think I might have mentioned it a little bit before, but we really do kind of keep our framework very agnostic to different ML technologies out there, because we want to make sure that if you decide to use a new ML framework, you can actually build it back into our infrastructure. And so we actually have what we call big head libraries, which you can actually build wrappers around common ML frameworks. And you have to kind of define your serialization and deserialization of it, as well as their fit transform. But essentially, you can add in any ML framework you want. And so we want to make sure that it's open so that if someone is very opinionated that there is an ML framework that works better, they can actually have the freedom to add it back into a system. And that also allows them to have their own Docker image, which they can use, and we'll use that same image for deploying into production. And so we make sure that we have this immense flexibility so that we can be adaptable to new technologies that emerge, new trends, and we always try to kind of stay on top of it to make sure that people have the freedom, just because ML is constantly moving, it is very dynamic, and once at least the infrastructure becomes opinionated, a lot of our downstream users then have this friction, and if there's a lot of friction, eventually they'll look towards maybe trying to find another infrastructure they can rely on. And so we want to be as flexible and as supportive as we can to our downstream users.
Pranav, can you talk a little bit about the Google perspective?
Sure. So I think as Andrew pointed out, extensibility is really important for ML infrastructure. One of the big reasons is because ML is in such a nascent stage. The use case themselves are still evolving, right? So if we build some infrastructure today for some use case that we know works today, from 2 years from now, the use case would have evolved very significantly. Users would have very different expectations. Like if I think about features like something like Smart Reply, which we launched a few years ago, it was something back then users didn't expect, and it was an add-on feature. But today, people are almost starting to take it for granted and are expecting like the next wave of features that would be driven by it. And how do you build infrastructure that can anticipate the next few years of product scenarios and scale with those? That's one part of extensibility. The second part of extensibility is how do we scale with the number of users or number of end applications. And I think a good rule of thumb is most ML systems that we develop today should scale to at least 2 orders of magnitude growth. When it gets to third order, then we probably need to rebuild or redesign the system. But something that we are building today for like some number of users can scale to 2 orders of growth, both in terms of, let's say, end users, or it could mean like internal number of teams that are using this infrastructure. So I think those are the two factors.
How are you thinking about it at Facebook?
So I think I heard a lot of the things that are very similar, making sure that we can use any of the frameworks that we need to. The one thing that we did slightly differently, which I alluded to earlier, which was a glue layer on top, is something that we call Fluent. The idea is to make sure that we have a declarative mechanism of being able to plug in whatever framework you want underneath. And we take care of doing the translation in between models. So you can actually create an ensemble model of PyTorch with Cafe2, with TensorFlow, with whatever it is. The idea being that one layer to the next is something that we take care of. It does run into challenges when we want to push this to influence. So those, if it's Cafe2 and PyTorch, we take it to production easily. If it's something else, it becomes a little harder. This has made a lot of differences. It's made a bunch of teams more productive. So for example, we have a bunch of integrity teams that can build now on each other's work. They can take a domain from, say, the feed integrity team can now reuse something that the messenger integrity team tried. And especially with FAIR, this becomes incredibly useful. PyText, which is the new text framework built on top of PyTorch is becoming incredibly useful because we exposed it on Fluent, so a lot of integrity teams can use it. There's a bunch of value in being able to make this happen.
Nice. So for the next round, we're going to go through each of the panelists, and each of them will dig in a little bit on what success means for them. So Aditya, since you've got the mic.
Okay, what success means for us. If I were to make it super simple, one, reliability. With distributed training, with new types of hardware, with different types of models and the scale that we're dealing with, we need to make sure that that's top priority. The second is scalability. Distributed training and accelerated hardware are what we're looking at to make this possible. Third, developer productivity. The idea that we actually need to make developers more productive, and we measure this in various ways. I think reliability and scalability are fairly simple. Developer productivity becomes very complicated because the number of stages that we go through in a pipeline are phenomenally large. So we actually have measurements for each of them. For feature engineering, we have measurements of how many features are shared, how quickly does a feature go from inception to production. With training, it is how quickly do you get to the point where you started writing an ML pipeline to the point that you finished and it actually went and executed successfully. With inference, how quickly were you able to get it to inference? Did you end up failing? Inference is actually, in my opinion, the closest to standard web infrastructure that we've seen. It's easiest to measure. It's something that we understand. And developer productivity as a whole, you have an idea how long did it take you to get from where you are till you ran an online experiment. And we still haven't figured out how to measure that one well.
So for me, I think it's going to be a balancing act across three things, right? Starting, the first one is around how do you maintain agility, especially like most of us talked about earlier, right? This space is changing very fast, and as platform owners, we have to stay ahead of the curve. And how do you make sure that you're able to cater to their business needs, be it hardware provisioning, ensuring libraries are available, while keeping up with the reliability of the service in general. I think that's the first one. The second one for me is, again, with innovation, right? I think as we need to keep up with the changing technology space, a lot of the ways we used to do traditionally won't be able to keep up with it, right? How can we quickly innovate with the sets of tools we apply, or the technologies that are out there? It could be around alert correlation, being able to automate recovery to a large extent without human interaction, so on and so forth needs to also change, and we need to innovate how we do things. And the last one is cost efficiency, right? While we need to cater to the business, there is also a huge supply chain and vendor management, and keeping up with the physical aspects of data center space and planning. How do I kind of balance all of these three things is how I would define success for our teams. So over to you.
All right, for us, a lot of things are similar, obviously, so we'll be sounding like broken records here. But the one key thing that perhaps comes slightly differently for us, and it's in the nature of sort of the place of our team, is researcher productivity trumps everything else. And so obviously there's, by everything else, there is no infinite cost. I mentioned that. But our most important metric is how quickly and how many A/B tests we are able to enable on our platform. How easy it is for a new researcher to come and really understand our custom platform and be able to run their first A/B test. So all of those things are the sort of the guiding principle through which we measure our success. Of course, our very close customers measure success in terms of how many product experiences they're able to push through, which is an important element for us too, but more important than the actual product wins are how much innovation have we enabled on the platform? How fast are people able to sort of try out new things in the Netflix product? That's how we measure ourselves.
Andrew?
So from a PM perspective, we tend to view it through some of these business metrics, which working on infrastructure is always a little bit difficult to quantify. Coming from the cloud world, I know that a lot of cloud services do it straight on revenue or profit. And so moving into more of an infrastructure team where it's harder to get to business impact just because we're a couple layers deep, we really break it down into number of users for a breadth approach to make sure that we have a good number of users and teams within the company using our infrastructure. And then for a depth approach, we look for number of models per users and teams, as well as kind of the QPS, which is more of just how many inference and how many scores are being generated per, whether it's online or offline, just to see whether we can increase the usage within our infrastructure as well. And then we also track kind of a lot of the infrastructure metrics as well: availability, scalability, latency, costs. And then we also tend to put a high importance on long-term decision making. This one's really hard to quantify, but it's something that I think is fundamental to infrastructure. The fact that one poor decision or a short-sighted decision could really lead to a lot of cost for a team. And it's always difficult to quantify that. It's always hard to justify it as well because you're preventing an accident from happening. And it's in that pros and cons kind of matrix and trying to figure out whether it's worth it or not. We tend to heavily emphasize it is worth it because infrastructure generally, as more use cases onboarded, hundreds of models, it's hard to iterate and it's hard to change things. And so we want to make sure that we make the right decisions up front. And it's something that doesn't, as a PM, I struggle with this, that it doesn't quantify to a number that I can track. But it is incredibly important to make sure that we don't end up kind of on fire where we can't really solve all the technical debt that we've accumulated, and we made a lot of poor decisions to get to that point. And usually that results in you build a V2 of the infra you just had and try to scrap it, and that's a whole big effort. And yeah, so overall we do put a lot of importance on that.
So everything I could have said has been covered. So the one slightly different angle I would add, which I think Sandhya hinted at, is the innovation aspect, right? And how much can the infrastructure that we are building today power the use cases of tomorrow? Like if there's one thing we know about ML, it is that the next 5 years, the use cases are going to look very different from the last 5 years, right? And how can the ML infrastructure systems that we are building today power those future use cases? And that is one lens with which I look at my systems is, are we really powering these new novel scenarios? Of course, yes, we can do the previous ones better, faster, more reliable, but can we power like really new ones, which a year ago most people couldn't even have thought of?
Yes, thank you. So now it's your turn to dig into us. So question time.
So all of you have.
Do you want to pass the microphone? Or?
I can just speak.
Yeah.
So all of you are working on large-scale ML, and in this last round, a bunch of you talked about developer productivity. So could you dig into that? I mean, what are the factors that impact developer productivity? Is it the kind of frameworks you use, the languages you use, the data you use? Could you shed some light on each of your own views on how that? And finally, it is about company success. It is about how quickly you can move that model back into production that gives you better results, that gives you better advertising revenue, that gives you better recommendation, etc.
I'm going to jump in. So it runs the whole gamut, right? And when it comes to productivity, right? Right from the start, when you're doing very early ad hoc explorations, and whether it's the right notebook environment where you want to see the visualizations and the data together, how easy it is to take an early inception feature into something that's more productized and ready to be launched into a production pipeline, and then how are you able to? How much time are you spending on understanding or dealing with the challenges of the platform versus the place where you should be spending your time on? How easy does the platform make it for you to debug your problems? So it's a whole dimension, much of which is not new, as software engineering in general has been dealing with this thing. The additional layer that ML adds is that suddenly data has been elevated to a whole new level. The value of garbage in will result in a perfectly wonderful software engineering system leading to a garbage out result. And that's the key thing, that data provenance, data quality, and how can the platform help with all of those things, which are now an additional element that research scientists have to think about. So there's a whole new set of problems, but also a lot of common problems that we've been dealing with for years.
One of the challenges, one of the dimensions that we've seen is the artifacts, the systems that get built with the ML are so complicated that for a long time, only the ML engineers could troubleshoot them. So if there was a bad job recommendation that comes down, someone complains to execs and it flows down, it's only the ML team that can work on it. And while they're working on troubleshooting that problem, they're not innovating, they're not driving new features, they're not building new capabilities. So one of the things that we've been looking at is, can we make the systems more understandable? Can we make it so that product managers, so that application engineers can troubleshoot and at least get the first 1, 2, or 3 layers of troubleshooting before it brings it to bring in the ML engineers?
So we face the problem that Joe was talking about, the problem that Faisal was talking about. I'll try and give you numbers. So in our case, distributed training at its maximum can last up to 28 days on several machines. And it's 28 days only because we stop it at that point. It'll go on. The other problem is that within those 28 days, if one machine fails, for whatever reason, your entire training is gone. You got to start over. So we had to come up with mechanisms of how to counter that. We have to come up with mechanisms of how do we make sure that if it fails within the first 30 minutes if possible, within the first day at worst. Because that is what engineers want to know. They don't want to wait 28 days to see whether or not something's going to fail. And ideally, we should be the ones telling them. It's the infrastructure provider that should be the ones telling them, not them finding out on their own. The reason for this is actually really simple. We've all invested in making these people more productive. When you make somebody more productive, they're going to do more. They're going to run more experiments. They're going to train with more data. They're going to try out more features, leading to a problem where anything failing, anything not working as they expected can have larger consequences. And which is why we invest a lot more in making them productive, but also providing the guardrails of telling them when something happens.
Yeah, if I may add one more thing. If you go down the stack, there's obviously thousands of machines supporting everything we do, right? For example, aging hardware, we do need to take care of that, right? I think we are working on a project to replace about 4,000 machines over a short period of time without impacting, like what Aditya said, right? Whatever is happening. Flexible infrastructure upgrades, like OS upgrades, I think those are all mundane tasks when you do it at a machine level, but when you have to do this at massive scale on live clusters, I think it is a very hard, complex problem to solve, and I think that's where how do we be agile and still be able to cater to the business needs is the balance.
Can we get another question?
Hi. It was a really good panel. Maybe this question is a little too specific, but still, I just want to hear your ideas on it. We know that when things are being deployed in today's operational world and today's data centers, at least most companies and most applications are now aware that they should be instrumenting their applications to a large extent to get good metrics out that they can then realize, come back, and then change their software accordingly. How does having machine learning models, machine learning applications impact monitoring as such? In the sense that, are there new things that we're supposed to monitor? Are we still using the old artifact, the CPU disk, memory, is that all? Are there other things that we should be looking for when we are trying to assess our qualities of predictions?
I can
Go ahead.
jump in and others can chime in. So I think we definitely have gotten better at looking at the machine stats, but I think we are at a point where we have to traverse the call graph. For example, a call to name node has to talk to multiple services like LDAP. It needs to make a call through the network, right? It needs to make a call through DNS. I think traversing the end-to-end graph, and though we have a ton of metrics, we do need to apply metrics correlation, because I think it's impossible for humans to traverse through dashboards and pinpoint where the problem is. I think that is the space we are dealing with, where though all the applications have gotten better at spewing metrics, finding sense of what's the most critical ones, how do we bubble it up, right? So that there's not a whole lot of noise and you can exactly pinpoint and get to it, I think is the hard thing. At LinkedIn, we have this application Third Eye, I believe it is open source now, where we leverage it today at the business metrics level, right, to identify the noise as to why there is variances. It could be holidays, it could be some of the new models that were rolled out, a new LIX RAM, like an experimentation RAM that went in. So we leverage platforms like Third Eye to kind of help us determine that rather than humans doing it. It's beyond humans at this point.
One of the things that's fundamentally different, I think, in ML is we have this idea of these features. And when we're in the inference world, many of the features are extremely ephemeral. And if I'm remembering right, Netflix had this idea of capture the facts, not just the features, and going back. So you want to quickly touch on that?
I can, but before I jump into that, let me just answer one part that I think you were asking, which is about what are the new metrics that are coming in the world of ML. And one key thing that's different from traditional software engineering monitoring is around sort of the distributions of the data and the distributions of the features. So feature importances that you're tracking as the various inferencing is happening in life. And sometimes data skews can be a whole interesting challenge to deal with, because if your data is skewed in a way which is not what you were expecting, your model metrics will be off substantially. So having those kind of monitoring is important. And to the point that Joel was bringing up about facts versus features, so one of the things that we have found that's a lot more easier to share are what we call facts. And think of facts as almost like ground truth or some incontrovertible happening. So for instance, somebody came to the Netflix website and they were impressed a particular video, and then they added that to their My List, and that they clicked play, things of those nature. And those need to be, they're far more easier to share because they're incontrovertible, and oftentimes can help building up a lot of the effort that goes into developing a feature from scratch. So I think that's the point that you were raising.
So we're going to wind up. We've got one last little bit. Each of us is going to move through and leave you one key takeaway. So.
I get it first. So I think the one takeaway I would give is adapt and evolve your ML infrastructure as the research world and product scenarios evolve.
Andrew?
That's a good one. Something else I think would be invest in the infrastructure side of it. ML infrastructure relies on a lot of pieces to go right for you to have really stable, scalable infrastructure, whether it relies on the data warehouse, whether it relies on other components underneath. And so what I find is to make an ML infrastructure really successful, it really does take kind of building that core infrastructure piece and all the dependencies underneath to be really stable so that you can build a lot of really cool use cases on top of it.
So full disclosure, Joel had given us a 5-word limit on the takeaway, so I thought really hard what I'm going to say. And my 5 words are researcher time over machine time.
That's a good one. So for me, again, it's 5-letter sentence, right? What gets measured gets fixed. That's an adage that we all try and strive towards.
I think that Andrew kind of mentioned this, build on stable infrastructure, because after you're done with that, you actually have to focus on the higher level pieces, what inference does, how to make people more productive. And having a good stable infrastructure will help you with that.
Thank you. So it's been a real pleasure working with all of you. I know that there were hands as the friction came down to ask questions and we weren't able to get to all of you. There's at least 2 massive social networks that are really valuable for reaching out to folks. I bet you can figure out how to find any of us if you have more questions to dig in on. Plus we'll be around. So thank you all. Thank you.
Thank you very much. Just one really quick thing. Another way to stay connected after the conference is there's a Slack channel. So please go ahead and join that. And I would like to ask the panelists to join that as well. Thank you, everyone.